Good day, everyone. We are now in topic 5.3 of our basic calculus subject, which talks about the definition of the derivative. The competency. At the end of this session, you are expected to relate the derivative of a function to the slope of the tangent line. Let us recall tangent line. Suppose there is a tangent line at point P on a curve, and Q is any point that lies on the curve and is different from P. If point Q will be moving along the curve towards P, the second line will rotate to a limiting position, which is considered to be the tangent line at P. So here is the situation. Suppose the point Q, which is here from the right and from the left, will be moving along the curve towards P. Then the second line will be rotating to a limiting position, which is considered to be the tangent line at P. The expression limit of f of x minus f of x of 0 all over x minus x of 0 as x approaches 0 computes more than just the slope of the tangent line. The fraction in the limit also gives us the relative change of the function on the time or space interval x sub 0x. Thus, we may interpret this limit as the instantaneous rate of change of f with respect to x. It is therefore fitting to make an abstraction out of this. Afterwards, we can regard this as a tool that can be used in finding the slope of the tangent line or in finding the instantaneous rate of change. In what follows, we are going to define the expression as the derivative of f of x at x sub 0. So we have here the definition that let f be a function defined on an interval I, which is a subset of the set of all real numbers, and let x of 0 be an element of I. Derivative of f at x of 0 is defined to be f prime of x of 0 is the same as the limit of f of x minus f of x of 0 all over x minus x of 0 as x approaches x of 0 if this limit exists. That is, the derivative of f at x of 0 is the slope of the tangent line at x of 0, f of x of 0, if it exists. Then we have notations that if y is equal to f of x, the derivative of f is commonly denoted by, we have y equals f of x, we can say y prime, or f prime of x. Then we have this one, the derivative of f of x with respect to x. This one. Then the second one is the derivative of, or derivative with respect to x of f of x. Okay, kani the derivative with respect to x of y. The derivative of y with respect to x, or you can read as dy over dx. Okay, so these are the different denotations for a derivative. Parihara na silang meaning tanan. Okay, for example, we are going to find f prime of 1 for each of the following functions. Okay, number 1, we have given f of x is equal to 3x minus 1. To find f prime of 1, we are going to find the limit as x approaches 1 of 3x minus 1, which is f of x, minus f of 1, wherein the x here will be replaced with 1, times 1 minus 1, all over x minus 1. Okay, so simplifying, copy limit as x approaches 1. Simplifying, we have 3x minus 1, and 3 minus 1 is 2. So we have minus 2 all over x minus 1. Then simplifying further, we have 3x minus negative 1 and negative 2 is negative 3. So 3x minus 3 all over x minus 1. After that, factoring the numerator by taking out the common factor 3, so we can have 3 quantity x minus 1 all over x minus 1. So we can cancel the x minus 1. So finding the limit of 3 as x approaches 1 is equal to 3, because the limit of the constant is the constant itself. Okay? Okay, let's proceed to number 2. Number 2 is f of x is equal to 2x squared plus 4. To find f prime of 1, we have to copy or limit as x approaches 1 of 2x squared plus 4 minus 2 times 1 squared plus 4 all over x minus 1. So it would be the same as x approaches 1, we have 2x squared plus 4. Then 1 squared is 1 times 2 is 2 plus 4 is 6. So this is minus 6 all over x minus 1. So simplifying the numerator, we have 2x squared minus 2 all over x minus 1. So factoring the numerator, we have taking out 2, we have x squared minus 1 all over x minus 1. Factoring again, we have 2 quantity x plus 1 times quantity x minus 1 all over x minus 1. So we can cancel the x minus 1. So thus we have the limit as x approaches 1 of 2 quantity x plus 1. Replacing or evaluating the limit, we are now, and this will be equal to 2 times quantity 1 plus 1 which is equal to 2 times 2, which is 4. So that's why f prime of 1 is equal to 4. Okay, next number 3. Number 3 is f of x equals 2x over x plus 1. So to solve f prime of x, or f prime of 1, so we have the limit as x approaches 1 of 2x over x plus 1 minus 2 times 1 over 1 plus 1 all over x minus 1. So it should be the limit as x approaches 1 of 2x over x plus 1 minus 2 over 2 all over x minus 1. Then, simplifying the numerator, the limit as x approaches 1, this will be equal to 1. That's why we have 2x over x plus 1 minus 1 all over x minus 1. Okay, since the denominator is x minus 1, we need to multiply both numerator and denominator by x plus 1. Okay, so that it will be the same as limit as x approaches 1. The denominator is quantity x minus 1 times quantity x plus 1, and the numerator is x plus 1. We have 2x minus x minus 1 times x plus 1. Okay, so we can cancel the x plus 1, and the numerator now becomes x minus 1. Okay, 2x minus x is x minus 1 over quantity x minus 1 times quantity x plus 1. Cancel x minus 1. What is left now is 1 over x plus 1. Evaluating the limit, it would be equal to 1 over 1 plus 1, which is the same as 1 over 2. Or the limit of, or f prime of 1 is equal to 1/2. Okay, let's proceed to number 4. Number 4 is f of x is equal to the square root of x plus 8. To find f prime of 1 is equal to the limit as x approaches 1 of the square root of x plus 8 minus the square root of 1 plus 8 all over x minus 1. So simplifying the numerator will be the square root of x plus 8 minus 3, because this is equal to 9 and the square root of 9 is 3 all over x minus 1. So since the numerator is binomial of square root of x plus 8 minus 3, we can multiply both numerator and denominator with the conjugate of the numerator in order to rationalize the numerator. We have the square root of x plus 8 plus 3 all over the square root of x plus 8 plus 3. So that the numerator becomes the square of the square root of x plus 8 minus 9, the square of 3 over x minus 1 times the square root of x plus 8 plus 3. Simplifying the numerator, it would become x plus 8 minus 9 over the denominator of quantity x minus 1 times quantity square root of x plus 8 plus 3, and the numerator becomes x minus 1, which can be cancelled to the denominator of x minus 1. Then copy quantity x plus 8 plus 3. So we now have an expression of the limit of 1 over the square root of x plus 8 plus 3 as x approaches 1. Evaluating the limit, it would be equal to 1 over the square root of 1 plus 8 plus 3, and this will be 1 over square root of 9 plus 3, which is equal to 1 over 6, because square root of 9 is 3, so 3 plus 3 is 6. Okay. So next is we have an alternative definition. That means we can find the derivative of a function using this formula. But let f be a function defined on an open interval I, which is a subset of the set of all real number, and let x be an element of I. And then the derivative of f at x is defined to be f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0 if this limit exists. So pwede po din nato gamiton yung formula, but taas-taas naman ang process. Okay, so let's proceed to example number 3. Suppose that the particle moves, or this example is an application of instantaneous velocity of a particle in rectilinear motion. That the derivative of a function is also interpreted as the instantaneous rate of change. So in here we discuss a particular quantity which is important in physics, the instantaneous velocity of a moving particle. So the general setting of the difference between the average and instantaneous rate of change will be presented in the enrichment section. So suppose that an object or a particle starts from a fixed point and moves along a straight line towards a point B. And suppose also that its position along the line segment AB at time t is s. Then the motion of the particle is completely described by the position function s is equal to s of t, wherein t is greater than or equal to 0. And since the particle moves along a line, it is said to be in rectilinear motion. So we have this example that suppose that a particle moves along a line with a position function s of t equals 2t squared plus 3t plus 1, where s is in meters and t is in seconds. What is the initial position? So in order to find the initial position, we have to simply solve for s of 0. Okay, so 0 man ta nag-start. So we are going to replace all the letter t with 0. So we can now have 2t or 2 0 squared plus 3 times 0 plus 1. So simplifying, therefore s of 0 is equal to 1. So this means that the particle can be found 1 meter to the right of the origin. Okay, next is where is it located after t, which is equal to 2 seconds. So after 2 seconds, we are going to find s of 2, which is 2 times 2 squared plus 3 times 2 plus 1. So we can simplify them, or simplifying, we can now have 4 times 2 plus 6 plus 1. So this is 8 plus 7, and therefore it is equal to 15 meters. So that means after 2 seconds, it can now be found at position of 15 meters. What about C? At what time is the particle at position s equals 6? So what are we going to do is s of t is equal to 6. So that means 2t squared plus 3t plus 1 is equal to 6. Okay, in order to solve for t, we are going to factor out the left side of the equation. So factoring 2t squared as 2t and t. Then, before that, we need to transpose for 6 to the left. So therefore, it would become 2t squared plus 3t minus 5 equals 0, because 6 becomes negative 6 plus 1 is negative 5. So factoring now negative 5 as plus 5 minus 1 equals 0. So from here, 2t plus 5 equals 0, we can have a value of t which is negative 5 halves, or the other one, t minus 1 equals 0, so t here is 1. So of that two, we cannot use time which is negatives, therefore we cannot use t equals negative 5 halves. So therefore we can choose t equals 1 second. Okay, so when the time is 0, the initial position is naa sa 1. Okay, when time is 1, naa sa 6 meters. When time is 2, naa sa 15 meters. Okay? Okay. So instantaneous velocity, we have let s of t denote the position of a particle that moves along a straight line at each time t is greater than or equal to 0. So the instantaneous velocity of the particle of time t equals t sub 0 is s prime of t sub 0 is equal to the limit of s of t minus s of t sub 0 all over t minus t sub 0 as t approaches t sub 0 if this limit exists. So let's proceed to example number 4. Example number 4 talks about a ball is shot straight up from a building. Its height in meters from the ground at any time t in seconds is given by s of t equals 40 plus 35t minus 5t squared. Find A, the height of the building, B, the time when the ball hits the ground, C, the average velocity and the interval of 1, 2, then the instantaneous velocity at t equals 1 and 2, and the instantaneous velocity at any time t sub 0. So to find the height of the building, we are going to solve for s of 0. So substituting, we have 40 plus 35 times 0 plus or minus the I minus 5 times 0 squared, and this would equal to 0. So 40 plus 0 plus 0 equals 40. So that means the height of the building is in the initial position of the ball. So the building is equal to 40 meters high. Okay, and in number 2, we are going to find the time when the ball hits the ground. So when the ball is on the ground, when the height s of the ball from the ground is 0, thus we solve the time when s of t is equal to 0. So solving, we have to equate okay, so from 40 plus 35t minus 5t squared equals 0. And dividing everything by 5, so it would be 8 plus 7t minus t squared equals 0. Okay, factoring.
Watch Candace tomorrow.
We have 8 and 1. We have minus t and plus t, so that we can have negative t plus 8t is 7t. Okay, solving, we have 8 minus t equals 0. So t therefore is equal to 8. And for the second one, 1 plus t equals 0. T here is negative 1, sorry. So we are not to use the negative value of t because there is no negative time. So therefore, we can say that the time when the ball hits the ground is 8 seconds. Okay, letter C is to find the average velocity on the interval 1, 2. So let us recall that to find this one, we are going to solve for s of 2 minus s of 1 all over 2 minus 1, wherein s of 2 is 40 plus 35 times 2 minus 5 times 2 squared minus quantity 40 plus 35 times 1 minus 5 times 1 squared. Okay, all over 1. Okay, which is similar to 70 plus 40 is 110 minus 5 times 4. So we have 40 plus 70 minus 20 minus 40, 75 minus 5, which is 110 minus 20 is 90 minus 70 is equal to 20 meters per second. Okay, so the average velocity of the ball on the interval 1, 2 is 20 meters per second. Next, letter D is the instantaneous velocity at time t equals 1 is, what are we going to do for letter D? Since we are to solve for instantaneous velocity, we have to solve the limit as t approaches 1, s of t minus s of 1 all over t minus 1 for t is equal to 1. And for t is equal to 2, we have the limit as t approaches 2 of s of t minus s of 2 all over 2 minus t minus 2. T minus 2. Okay, so in this case we have 40 plus 35t minus 5t squared minus, we have already solved s of 1 a while ago, which is equal to 70 over t minus 1, which is the same as 40 plus 70, 40 minus 70 is negative 30 plus 35t minus 5t squared all over t minus 1, in which we can factor this common factor of negative 5, which is we have t squared minus 7t plus 6 all over t minus 1. The numerator can be factored as negative 5 quantity t minus 6 times t minus 1 all over t minus 1. Cancelled out ni. So therefore, napa din yung mga limit din ha. As t approaches 1, napa ni limit as t approaches 1. Limit as t approaches 1. Napa ni limit dere. Okay, so therefore it's equal to the limit as t approaches 1 of negative 5 quantity t minus 1 t minus 6. So evaluating, we have 1 minus 6. 1 minus 6 is negative 5 times negative 5. Negative 5 times negative 5 equals 25 meters per second. Okay, at t equals 2, we are now to solve the limit of st minus s of 2 all over t minus 2 as t approaches 2, which is equal to the limit of as t approaches 2. We have 4t plus 35t minus 5t squared minus ang 2 ganina is s sub 2 is equal to 90 sa atong na-solve kanina sa C. Okay, all over t minus 2, which is equal to the limit as t approaches 2. 40 minus 90 is negative 50 plus 35t minus 5t squared all over t minus 2. And the numerator can be factored as a negative 5 quantity t squared minus 7t minus 10. No, plus 10. Okay, all over t minus 2, in which we can factor this one as the limit of negative 5 quantity t minus 2 times t minus 5 over t minus 2. Cancelled out, and evaluating the limit, we have negative 5 times as t approaches 2 negative 3 equals 15 meters per second. Okay, so therefore the instantaneous velocity at t equals 1 is 25 meters per second, and at t equals 2 it is 15 meters per second. Okay, what about the instantaneous velocity at any time t sub 0? Okay, so we are going to find an E to find the limit of s sub t minus s of t sub 0 all over t minus t sub 0 as t approaches t sub 0, which is equal to the limit as t approaches t sub 0 is equal to, or it would be 40 plus 35t minus 5t squared minus quantity 40 plus 35 t sub 0 minus 5 t sub 0 over t minus t sub 0. So, cancel out ang 40 and 40. What is left is we have the limit t approaches t sub 0 is 35t minus 35t sub 0 minus 5t squared minus 5t sub 0 squared and squared, sorry, all over t minus t sub 0. And this would be similar to the limit of t approaches t sub 0. This one, we have common factor 5 for all. We have t minus 7t sub 0 minus t squared minus t squared, t sub 0 squared. Seven t minus t sub 7t sub 0 and minus t squared t sub 0. So in this 2 here, we have common factor na pod t of t sub 0, t minus t sub 0. So it would be the limit of t as t approaches t sub 0 is we have 5, and the common factor na pod is t minus t sub 0. Then we have 7 minus t plus t sub 0 all over t minus t sub 0. So we can cancel this one, and what is left is we have 35 minus okay, kadali sa kay murag na wrong dere. This will be positive kay 35, then this one is negative, and then negative, then this will be positive. So this is positive, and kaninga part tempa na we have 5. The common here is 7. We have t minus t sub 0 minus 1 of t minus t squared minus t sub 0 squared all over t minus t sub 0. So this one can be factored. So it would be equal to the limit as t approaches t sub 0 of 5 times quantity 7, t minus t sub 0 minus 1, kani ma-factor na nato as t minus t sub 0 times t plus t sub 0. Okay, and for these two, they have common factor nga kani. So that's why over paniha it would be limit as t approaches t sub 0 is 5, and then common factor ang quantity t minus t sub 0. Then we have 7 minus quantity t plus t sub 0 all over t minus t sub 0. So cancelled out ni. Okay, that is why when we evaluate, we have equal to evaluating the limit. It will be equal to 5 times 7 is 35 minus kay t absorb ang t mapulihan man natong t sub 0. So t sub 0 plus t sub 0 is 2t sub 0. So 5 times 2 is 10 t sub 0 minutes meters per second. Okay? Okay, ang t, as t approaches t sub 0, so t becomes t sub 0. So t sub 0 plus t sub 0 is 2t sub 0 times 5 equals 10t sub 0 squared. Okay? Example number 5. Suppose the costs in pesos of manufacturing X liters of a certain solution is given by C of X equals 20 plus 5x minus 2x squared plus x cubed. Compute the average rate of change of the cost to Y of producing X liters over A 1,4 over the interval 1,4, second interval 1,2, and third interval 1,5. So in order to solve this one, we have to compute the different values of, for I, we have the interval 1,4. So we are going to solve C4 minus C1, C of 1 over 4 minus 1. So C of 4 is equal to C of 4 equals 20 plus 5 times 4 minus 2 times 4 squared plus 4 cubed, which is equal to 20 plus 20 minus 16 times 2, negative 32, plus 64 equals, we have, pila naman ni, 40, 104, or 32 plus 20 is 72. So this is 72 minus C of 1 is equal to 20 plus 5 minus 2 plus 1 over, is equal to 26 minus 2, 24. So that's why 72 minus 24 over 3. So the answer is 48 over 3 equals 16 pesos per liter. Okay. Number 2 is interval 1, 2. So kaya na naman tayo 1, 2 na lamay itong pangitaon. So C of 2 minus C of 1 over 2 minus 1. So pila man ang C of 2? C of 2 is 20 plus 5 times 2, 10 minus 2 times 2 squared is 4 plus 2 cube is 8. We have 30. Okay, negative 8 plus 8 equals 0. So it would be 30 minus 24 over 1. So it would be 6 over 1 or 6 pesos per liter. Okay. Then next is number 3, the third one. The third one is 1.5. So it would be C of 1.5 minus C of 1 all over 1.5 minus 1. So C of 1.5 equals 20 plus pila man og 1.5 times 1.5 times 5 equals 7.5 plus minus minus 2 times 1.5 squared, 2.25 plus 3.375 equals, itong i-add 3.375 plus 20.75 minus 2 times 2.25. Five times 4.5 plus the answer is 26.375. So it would be 26.375 minus 24 over 0.5. So the answer is 4.75 pesos per liter. Okay? Okay, example number 5. Suppose, the average and instantaneous rate of change. Suppose f is a function and y equals f of x. So the average rate of change of y with respect to x on the interval x of 0, x is delta f over delta x equals f of x minus f of x of 0 over x minus x of 0. And the instantaneous rate of change of y with respect to x at x equals x of 0 is the limit of delta f over delta x as delta x approaches 0 is equal to the limit of f of x minus x of 0 minus f of x minus f of x of 0 all over x minus x of 0 as x approaches x of 0 is equal to f prime of x of 0. Okay, example number 6. Verify that the instantaneous rate of change of the cost function above at x equals 1 is equal to 4 pesos per liter. So what are we going to do is to recall that the instantaneous rate of change of a function c at x equals 1 is precisely the derivative of c at x equals 1. But since we have ganina nga c of 1 is equal to 24, so our c prime of 1 is equal to the limit of c of x minus c of 1 all over x minus 1 as x approaches 1. And this will be equal to the limit as x approaches 1 of 20 plus 5x minus 2x squared plus x cubed minus 24 all over x minus 1. So it would be the same as the limit as x approaches 1. We have 20 plus, diretso na ta. So 20 minus 24 is equal to negative 4. So negative 4 plus 5x minus 2x squared plus x cubed all over x minus 1. Okay, if you are going to divide the numerator by the denominator using the long method or the synthetic division, the answer would be the limit as x approaches 1 is equal to x squared minus x plus 4. So thus, when we evaluate 1, the limit of this one as x approaches 1, it would be equal to 1 squared minus 1 plus 4, which is equal to 4. Okay? So that is why we can say that the instantaneous rate of change of the cost of function at x equals 1 is equal to 4 pesos per letter. Okay, so that's all for topic 5, because the first two topics are quite review of your knowledge in junior high school. So wa na himuhi og video lessons. So in a way, wa pud na gi-appeal sa atong assessment. So that would be all for this lesson, this topic number 5. And thank you for listening and watching. See you next time. Bye.